We are studying the chemical reactions of ether, in which we will study the reaction of ether with halogen acid. In this topic, the cleavage of carbon and oxygen bond takes place. Whenever ether reacts with halogen acid, they form alcohol and alkyl halide. So, ROR is the ether. When ether reacts with hydrogen halide, it forms alcohol and alkyl halides. If the halogen acid is taken in large quantity, then only alkyl halides will form. For example, if we take ROR, that is ether, so in the initial steps, only alcohol will form and alkyl halides will form. The alcohol so formed will combine with the halogen acid so that it can liberate 1 mole of water in this manner, and R and halogen will combine to form RX, or simply we can write the reaction in single steps in this manner. When methoxymethane combined with hydrogen iodide in excess, so methyl iodide will form with the liberation of water molecule. If the ether is asymmetrical, then the alkyl halides so formed will be from the smaller alkyl group. For example, if we have methoxyethane, then the possibilities will be methyl alcohol or ethyl iodide. But the products so formed in this reaction will be methyl iodide and ethyl alcohol, not methyl alcohol and ethyl iodide. So this point should be kept in mind that whenever unsymmetrical ether reacts with alkyl halides, the smaller part will always form the alkyl iodide. Similarly, in the case of alkyl aryl ether like anisole, this is anisole. It is also called as methoxybenzene. So, when methoxybenzene or anisole react with hydrogen iodide, the smaller part will form the alkyl halide and the bigger part will combine with the hydrogen to form phenol. Here, the reason for the formation of phenol is the double bond character which is formed between the benzene and the oxygen of ether group due to resonance. Hence, it is difficult to break that bond. In another condition, when ether does not contain any tertiary alkyl groups, the alkyl halides always attacks the smaller ion. That means the smaller alkyl groups will form the alkyl halides. For example, if we react ether which does not contain the tertiary alkyl group, the bromine will combine with the methyl groups to form methyl bromide, and the remaining part will form the alcohol. But if this reaction will be explained by the mechanism of the reaction, when the ether does not contain tertiary group, the ether contains oxygen of ether contains lone pair of electrons on oxygen. These lone pair of electrons attacks the proton obtained from acid. As a result, it forms protonated ether with the formation of halide ion. The halide ion so formed the halide ion so formed reacts with the protonated ether which is obtained from the first step, and a transition state is obtained in which the iodine starts forming the bond with the methyl group, and the methyl group start breaking the bond with the oxygen, and finally the alcohol is formed along with the formation of methyl iodide. Similarly, if the ether contains a tertiary alkyl group, the halide ion will attack the tertiary alkyl group by SN1 mechanism. For example, in the given reaction, the ether contains tertiary alkyl group. So, the iodide ion will attack the tertiary group to form tertiary alkyl halide, and the smaller part will form the alcohol. This can be explained through the mechanism of the reaction. The reaction is SN1 mechanism in which the ether first break into its respective ion, that is carbocation and methoxide ion. The carbocation so formed will combine with the iodide ion obtained from hydrogen iodide, and it forms the alkyl halide, and the methoxide ion so formed will combine with the proton obtained from the acid, and finally alcohol is formed. So here we have to remember both the condition. The point to be noted here is that hydrogen iodide will be more reactive than hydrogen bromide and then hydrogen fluoride, because the size of iodine is greater than bromine and that of chlorine. So in simple steps, we can say the mechanism of reaction takes place in two major steps. In the first step, protonation of ether takes place. The ether contains lone pair on oxygen. The electrons attacks the proton obtained from acid and form protonated ether. The protonated ether so formed is attacked by the nucleophile, which is the halide ion, and the formation of alkyl halides and alcohol takes place. The question regarding the topic is write the mechanism of the reaction of HI with methoxymethane. The solution will be we know in first step protonation of methoxymethane takes place. That is, the lone pair of electrons present on oxygen of methoxymethane attacks the proton, and as a result protonated alcohol is formed, and iodide ion is liberated as nucleophile. In the second step, the attacks the nucleophile iodide ion attacks on the protonated ether to form an intermediate. The intermediate result into the iodomethane and methanol. And in the final step, if the hydrogen halide is taken in large quantity, then the methanol molecule so formed will convert to methyl iodide. For example, the methanol so formed will again react with HI to form methyl iodide. Since we know the oxygen contains lone pair of electrons on it, and these electrons attack the proton obtained from hydrogen iodide. As a result, it forms protonated alcohol, and iodide is liberated as nucleophile. The iodide so obtained will attack the protonated alcohol to form methyl iodide and water.